Hello, this is Mr. Parseghian again, and I am going to talk with you guys today about separating mixtures and separating compounds. So earlier you learned about a mixture being a combination of more than one pure substance, and in order to separate mixtures we can use different physical techniques. So for example, if we had a mixture that was composed of a solid and a liquid, we could pass that mixture through a porous barrier, a barrier with tiny little holes in it, in order to allow the liquid to pass through and then collect the solid in that filter. And a good example of that is sand and water. So sand and water, sand of course in the solid phase, water in the liquid phase. If you passed it through a filter, something like a coffee filter, then we would be able to collect the sand in the filter and the water would pass through. So filtration is a technique that uses a porous barrier to separate a solid from a liquid. A good example of that is the separation of sand and water. Now, all mixtures will not be a solid and a liquid. Some mixtures may be a liquid-liquid mixture. And so if we've got a liquid-liquid mixture, we use a different technique to separate those two liquids from each other. And that technique is based on the difference in boiling points of those liquids, and it is referred to as a distillation. And so a distillation is a technique used to separate two or more liquids based on differences in boiling points of the substances. And a good example of that is the separation of an alcohol and water. And I am going to show you guys an example of a distillation. Okay, so here we see an example of a distillation. And just to kind of talk a little bit about what we've got going on here. You guys can see that we've got that tube, and I am running cold water through the bottom of the tube, and it's coming out on the other end and just filling into the sink. That tube is called a condenser, and so when we vaporize the mixture, or at least part of the mixture, when that vapor goes through the tubes in that condenser, then it will condense the captured vapor back down into the liquid phase. So you can see there I am lighting a burner, and with that lit burner I've got an orange colored solution. The orange colored solution is a mixture of a couple of different liquids, and I am going to heat that up. You can also see up at the top there's a thermometer, and that thermometer is positioned in the neck of the flask. That way when the first liquid vaporizes, I can get the temperature that liquid vaporizes at, and then that liquid, once it's vaporized, will pass down into the condenser, and it will come out down on the other end, like this end right here is the end that we're talking about. The first liquid that has the lowest boiling point will be removed and then collected here as the distillate. So it's going to take just a second for us here in order to reach the boiling point of the liquid. I actually think we're fairly close to doing that at this point. And then once that happens, we will be able to collect the distillate. And again, we're almost there. Okay, here you can see, if you look at the flask, the liquid is starting to boil. Then the vapor is being forced down the tube, and it may be actually hard to see in this video, but I think you will see that the distillate actually is coming out into the beaker there. One thing to recognize is the temperature that is boiling, the boiling temperature of this solution is 80 degrees Celsius. Therefore, we know that it's not the boiling temperature of water, which is 100 degrees Celsius. So although the solution, the distillate that's coming out of the solution is a clear liquid, it in fact is not water. In this case, it happens to be ethyl alcohol. So the mixture is composed of water and ethyl alcohol. And once the ethyl alcohol is removed from the mixture using using distillation, then the water could be removed as well, but not until all of the alcohol is removed. So these are both physical separation techniques, which is what we use to separate mixtures. However, if we want to separate a compound like water, which is H2O, then that requires us to use a chemical separation technique. And so I'm going to give you guys an example of that as well. The chemical separation technique that we're going to use is what we refer to as electrolysis. Electrolysis is used to separate a compound chemically by using an electric current. And so I'm going to show you guys a demonstration of separating water into hydrogen and oxygen gas by running an electric current through it. All right, so in the first video here, you can see that I've got a piece of glassware, and the glassware is called a Hoffman apparatus. I am just going to pour water into the Hoffman apparatus from the top, and then you'll see it fill the two tubes on the side, which have openings to the outside air, the outside atmosphere. So you can see the water is filling up here. Once I have the two tubes completely filled, I've got a little air bubble there. Now I am going to clamp off the two tubes so that no air can get in and no gas can escape. So there's the first tube clamped. And there's the second tube clamped. Now I am going to hook up a battery power source. So I've got the positive electrode there, and that is hooked up to a platinum electrode. And then I've got the negative electrode there, also hooked up to a platinum electrode, and that is going to allow me to pass an electric current through the water once I turn the power on. There we go. And now you can see that I have bubbles forming at the two electrodes. If you look at the one on the left, you can see it looks like that there is significantly more bubbling than the electrode at the right. And so what's going to happen here is that the gas will rise to the top, pushing the water down and up through this tube into the reservoir up at the top, and hydrogen and oxygen gas are going to form. Okay, so here you can see sometime later we have gas formed on the left and gas formed on the right. And you can tell that the gas formed on the left is more than the gas formed on the right. In fact, it looks like it's about twice as much. The reason for that is that when water decomposes, it decomposes to a ratio of 2 hydrogen molecules for 1 oxygen molecule. So the gas that you see there on the left is hydrogen gas that's formed, and the gas that you see there on the right is oxygen gas that's formed. And I'm going to do a little bit of experimentation with both of those things. All right, so first here with the oxygen gas, I'm going to collect the oxygen gas, and we know that oxygen is required for anything to burn. And so what I'm going to do is I'm going to have a wooden splint, a little wooden stick that I'm going to blow out and leave it as a glowing ember. And I am going to collect the oxygen gas here and reignite that glowing splint, and it goes very, very quickly with the oxygen that is collected in the test tube. Yep, and it was real quick, but you can see we reignited that wooden splint, and that was due to the oxygen that was collected from the Hoffman apparatus. Okay. The final thing that I'm going to show you is what happens when we ignite hydrogen gas. So I'm going to collect the gas from the other side, the hydrogen gas from the other side, and I'm going to ignite that as well.